Welcome to this tutorial on how to build a RESTful API with Quart. My name is Philip Jones and you can find out more about me here and more tutorials linked to here. Okay, so let's get going. So if you haven't heard about Quart, Quart is a re-implementation of the Flask API using async await. So if you're familiar with Flask, then you will be pretty familiar and able to use Quart. Alongside everything Flask can do, it can also do some particularly asynchronous stuff such as WebSockets and streaming responses, that kind of thing. But we're going to focus on building a RESTful API, and to do so we're going to use two Quart extensions. First, Quart-DB we'll use to manage the database and connect to it. And for this tutorial I'm going to use an SQL-like database because it's the easiest to set up. The second extension we're going to use is Quart-Schema. Now Quart-Schema is what we're going to do to really make the RESTful API very useful, and that's because it provides two things. One is validation of the request data and the response data, so it checks that the data is structured as we'd expect, and it's going to use that validation information to auto-generate API documentation, which I'm going to show as well. And by this I mean what's commonly called Swagger or Open API. Okay, with that said, let's get going. So today I'm going to use Python 3.11, which should be released tomorrow. I'm going to use the last release candidate. And the reason I'm going to use this, and this is a bit of an aside, but I think it's important, is because this version of Python has been compiled against a recent version of SQL-Lite. And this is important because I'm going to use some SQL syntax that is only supported in SQL-Lite versions greater than 3.35. And on my computer, this only happens to be this version of Python. You can actually link them all. But this is something to check, especially if you get weird errors about syntax, if you follow this example. Okay, now I am going to use 3.11, but you can use any Python version. I'm going to use syntax for Python 3.10 onwards, so 3.10 is what I recommend. Okay, first things first, let's create a virtual environment and activate it. Oops. There we go. And I'm going to install Quart. I'm going to install Quart-DB with the SQL-Lite extra. And I'm going to install Quart-Schema. So as those install, you should get one of those. And just for reference, I'll show you the versions of everything that's been installed. So the key ones: Quart-Schema 14.3, Quart-DB 4.1, and Quart 18.3. Okay. Right, so let's get started. First thing to do is create a very basic app. So to do this, we need to import Quart and create an app. So if you're familiar with Flask, everything I'm going to do here is going to look very similar to what you've been doing for a long time. And I'm going to create a very simple hello world root. I keep writing get, I mean def. And this is going to return hello. And now we can run it. So to run a Quart app, you just tell it where it is and use the command run. So it's Quart run, you can tell it where the app is. And this says it's running here, so I'll copy that. Let's take a look. And indeed it is. But if we take a look at the response, we see that this actually is HTML. So for an API, we're much more likely to have and want JSON, so a modern API that is. So I'll change this to return a JSON. So for Quart, if you return a dictionary, it interprets that as JSON. So let me restart the app. But as I do so, I'm going to turn on the reload flag so that every time I change the code, it restarts the app for me. Now if I refresh this page, see it's now looking like JSON, and it is in fact JSON. So that's good. I'll just close this so you get a better view of what it actually is. Alright, so we have a basic app running. So let's first create and connect to the database. To do that, we need to first initialize Quart-DB. Now I said earlier we're going to use a SQL-Lite database, and we're going to use one that saves its data to a file called database.db. Now Quart-DB, as the app loads, you saw it reload there and come up here, will create a database file for you, and this is where it will store everything. So with that set up, we can now start to create the structure of the database. And for Quart-DB, this works via migrations. So if we create a migrations folder, and within which we create the first numbered migration, which is 0.py. Now, a migration for Quart-DB needs to have two functions, both of which will accept a connection as an argument. The first function is the one that actually does the migration, and it has this signature. The second function will check that the migration is valid, and this has this signature. Now in our case, we're just going to create a table, so it's trivially valid. But you can imagine more complex migrations where you alter the data structure and alter the data within. You might want to check that things have actually gone to plan. So for us, we want to create a database. So we just use the connection, execute, and we're going to go create table. And this is the first time to ask the question, what are we actually going to create here? Well, I think we should create a Anki Cards interface. And if you're not familiar with Anki Cards, they are revision aids whereby you have a question on one side and an answer on the other. You read the question, you see if you remember it, then you look at the answer and find out whether you have. So if we're going to represent this in a database table, we need an ID. It's key here to write integer with SQLite, otherwise this won't auto-increment. It's a weird quirk, so it has to be that exact phrase. So it needs an ID, a question, and an answer. Okay. Whoops. And that should do it. We should see, if I restart it manually, it should now take an account of that and created this table in the database, which is excellent. So now we have a database with the table we need. And the final bit to note about Quart-DB is it puts on the G, which is a Quart global, a connection. So this is where we can do all our actual queries of the database as we need to do so. Okay, right, we don't need that right now. What we're going to do next is start setting up Quart-Schema. So, much like Quart-DB, we need to initialize it. So let's do that. If I can spell. Quart-Schema. Okay, so now as that saves, what it should have done already is, no, it's not running. Oh, it is running. I was just a bit too quick. It should now create a documentation. So this is the auto documentation that Quart-Schema does. And you see that it's picked up that we have one root in our app, which is this get root, which isn't particularly helpful, but that's all we've got so far. Also, I'll note that there's a redoc version of this, which is here. I find Redoc's UI to be slightly nicer, but it's up to you. You can go between. And of course, there's the actual Open API schema as well. So Quart-Schema does all of that, and you'll see this flesh out as we add all the roots. So let's start. So we're going to build a CRUD API. So the first root we need is one to create an Anki card. So I'm going to do this. I'm going to call it create card. And let's give it a doc string because that'll show up in the doc. So create a new Anki card. I'm sure you'll add something a bit more prescriptive. Okay, so how do we create a card? Well, we're expecting the user, when they create a card, to send us a question and an answer. So I'm going to specify that using a data class. So let me import that first. So data class. I'm going to call this card input. This is the input data. And this is going to consist of a question and an answer. No real surprise there. Now I'm going to use Quart-Schema's validate request decorator to validate that the JSON sent to this root has this structure, i.e. has a question and an answer. And if it does, this data argument will be populated with that. So now I have that, I can put it into the database. So now I can use the connection. I'm going to do a fetch, and you'll see why in a second. But what I want to do is insert into cards. I want to insert the question and the answer. give it the values. So Quart-DB uses named parameters throughout, so it has this format. I think name parameters are the safest way to do it, so I would definitely use these rather than positional parameters, which is the other option. Now, this is the bit which requires that later, or this modern version of SQLite that I was mentioning. And I can show you, if I show you the SQLite docs, so returning allows you to return the values that it's inserted and created in this case, but it's only supported in 3.50. Now you can get around this without returning if you've got an older version, but it's nowhere near as nice a syntax. So I think this is quite well, a really good addition. So that's why I'm going to use it. Okay, so we need to pass in the data. We want to pass the database. So it's data.question, and answer is data answer. Now you may notice here that I could have actually done as dict if you're familiar with data classes. But I've just spelt it out just to try and make it obvious. Okay, so we've got a result, and I think it's fair to say that what would be useful to return to the user is the card they've just created. So let's define that as a data class as well. Class card. In fact, it can inherit from card input because all it does is adds a ID. So we're going to say that this function returns a card, and we'll validate the response as well, which I forgot to import. So this means that Quart-Schema is going to ensure that the data sent to this function is the card input, and the data that it responds with is the format of the card. And this works like this, the card, and then you can unpack the results into the card like so. So if I save that file, it should now reload. There we go. And if I look at the documentation, it should now have a get cards, which of course doesn't make any sense because we're trying to create, so I need to switch that to post. So let's try that again. Post cards, create a new Anki card. Let's try it out. Does this work? The answer should be yes, let's hope so. Execute, response is, let's come back. Does this work? Yes, ID 1. So we've created our first card. Excellent. So that's the create part of the CRUD API we're building. The next part, the R in CRUD, is the retrieve or the read. So in this case, let's get the cards. So in this case, we want to get all the cards. So when I'm thinking about function, it's like get all. I'll just call it get cards. What we really want to return here is some kind of card structure, which I'm going to define as so. A list of card. Makes sense, I hope. Let's validate the response as well here. It's going to be recards, and then we just need to get the results. So how do we do this? I think the nicest way to write this is as follows. Oops. Card from the row. And this is kind of going to seem a bit backwards as I wrote it through, but hopefully you'll see. For row in g.connection.iterate select ID question answer from cards. I hope that's readable. Might be a bit more readable if I split out the query actually, so let me just do that. Just to try and make it a bit more pleasant to read. So you can see here, these are the cards. So I create them by fetching each row from the database, unpacking it into a card. So then I have a list of cards, which means that then I can return cards as so. That saves. Should now be in the documentation. It is. Now if we try it out, execute, we should get an answer with the one card we've added. Perfect. So that's the R part. Next one, update. So for this, I think it should be a put. And I think in this case, we define the ID as a path parameter. So we want to update this entire card. Much like with the create, I think we want to put the full card data, so card input, I would say here. So let's do update card. Oh, I just realized I forgot to do something. So I mentioned earlier, I'll just pause here, but I mentioned earlier, got this bit of documentation here, create a new Anki card, which I forgot to do on get cards, but that also shows up in the documentation. You can see it there. So anyway, slight digression. Sorry, I forgot to tell you about that. Let's carry on. So this update route, I think, should take the card data, the card input data, but return the card as you changed it to. So you know at the end of the update what it actually is you've changed it to be. So again, we just do that. So it's g.connection.fetch1. So we're expecting to only change one. How do I put it? We only expect to change one row. So we're going to do update cards, set question equals question. Oops. Again, named parameters, much safer. Answer where ID equals ID. Perfect. And so here we have ID is ID. I just realized I forgot to put that in as a positional argument. It comes from the path. And question is data.question, and answer is data.answer. Now, there is a possibility here that the result is none in a case where we have not, where we've provided an ID that doesn't represent or isn't in the database. So, if it's none, we want to return 404. Now in Quart, we can do that by aborting. So if I import this, abort, and that means that this will 404 if there's no card to return. And then finally, we just return the result like so. So hopefully that will make sense. We're updating the cards, we set it all. So let's have a look in our API. Here's our put. Let's try it out. So ID1, question, will this work? Hopefully it's still yes. Let's execute. Our response is exactly as we expect. And then just as a check, we fetch all the cards. Still yes. Perfect. So that works. So that's CRU in the CRUD. The last part is just a delete. So here we go. I think again, we want to name the card we're going to delete. Or use the ID, sorry. This doesn't actually need to return anything at all. And doesn't need to take an argument either. So in this case, I'm going to say that it's going to return just an empty string. And that'll be sufficient, I think, in this one. So what do? But it does need to take a ID, which I forgot again, which comes from the path. So await g.connection.execute delete from cards where ID equals ID. And then we just, again, name the parameter as so. And that's it. And we will just return a empty string. So now we should see this if we refresh this page. Here's the delete. So if we try this for an ID that doesn't exist first, it should succeed. Just a 200, fine. Now if we do it for the one that does exist, again, just a 200. Now if we go back and get the cards, you should see that now there is no card. They're empty. Perfect. So there we have it. CRUD API done in Quart. Whilst we're here, let's go a little bit further and write a couple of tests, shall we? While we're at it. So, PyTest async. So to run the tests, we're going to use PyTest, and we're going to need PyTest async because we're writing async code. Okay, that's good. So the first thing we need to remember to do is make sure that startup and shutdown happens during the testing. And there's a little fixture here recommended for it, which is this one. So I'm going to take this fixture but adapt it to our use. And it's this test app that's the important thing. So let me put this in. So this needs to be an async fixture in this case. It depends how you use async. I'm not going to get into the details here. But we also need to from app, import the existing app. So we've got app. I just now need to do the naming. So I can't call this app. I'll call it test app. Call this test app. So it's got a different name. And now this fixture can be used in any other function. So if we were to test, what's our first function called? Create card. Test create card. We can pass in that test app. And by the way, this test app has a type which is effectively Quart, a Quart instance. So I'm going to call it that. Quart. Let's do that just so it's a bit clearer. So first thing, we need test client, which we can get from the test app, like so. And then we're going to use the create. So we want to do test client.post, and we'll post into the cards. We'll pass in JSON data. That JSON data needs to be a card input, question and an answer, of course. Question, test, question, answer, ooh, can't spell, test, answer. Right, let me just try and clear that up. I recommend you use black, by the way, which I should have turned on. I didn't get around to it. So test create card, it's going to do that. Let's assign that to the response. Let's just check two things. What? A, that the response status. So the response status code is 200, i.e. it's worked. And crucially, that we have a ID in the response data, which I forgot to get out. So await response get JSON. So the ID is in data, and the data question is the test question. So data answer equals test answer. Okay, so that should do. So let's try it. PyTest tests. It skipped it. So the reason it skipped it is because we need to mark this as an async test. Now there's a way of not doing this using the auto mode. I can't remember the configuration option at the moment, but if you're using PyTest async, I'd recommend changing it to the auto mode. Then you don't have to write this everywhere. There we go, that one's passed, that's good. So at the same time, let's show you what happens if you don't if you don't pass the right thing. So let's say that typo I made actually goes through. I'm going to expect a 400 response, right? I'm going to expect the server to say you've made a bad request. So let's try that. They're both passed. Excellent. And that's pretty much it. So I hope that was useful. You can obviously extend these tests to cover all the other functions. I recommend you do. Like I've been pointing out, you get all the auto documentation. I recommend you add some more actual documentation to it. And you get it in the two forms, and it's totally up to you. Oops, I haven't got the app running, but if I restart the app, I recommend, oops, not Redux, it's Redoc. Huh? Oh, it was Redux, my mistake. I recommend Redux, it's quite a nice interface, especially when you add all the documentation. Well, that's this tutorial. I hope it was useful. And if it was, and you like the way I explain things, I encourage you to take a look at my book, which is a blueprint for production-ready web applications. So this is what it looks like. The entire code for it is available online in GitHub, so you can see it all here. And this repository is a working repository. The actions do exactly as they're described in the book, and the actions themselves manage this working app at tozo.dev, which you can log into, well, you can register and log into, and in this case, this is for managing to-dos. So if that interests you, please do take a look. If you want to find out more, it's at bgjones.dev/tozo, tozo being the code name for the app. Okay, thank you. I hope you have a good day.